And if we calculate this value is coming out to be 42.8, closely about that. So here 42.8 is 8 meters is nothing but the distance covered during these 3 seconds. So here final value you can write down 42.8 meter. So the area is nothing but the distance. The third question in this part A is nothing but the terminal velocity of the plastic ball. So what is the terminal velocity? It is nothing but the constant velocity that is achieved by an object which is falling freely under the gravity. Here you can see the plastic ball is starting from zero velocity. As the time increases, the speed increases, and here the rate of increasing the speed decreases, and after that it is achieving the constant value. That means it is increasing slowly and then it achieves the constant value. And it achieves the constant value, that is nothing but, you can see here it is closely about the 15 seconds. So it is nothing but this value. This is exactly the fifth division. You can see this is 10, this is 11, 12, 13, 14, 15. So this value is nothing but 15 meter by second. Okay. For this horizontal line, the value on the y-axis is 15 meter by second. So this is the constant value achieved by the plastic ball. So the plastic ball, the terminal velocity is nothing but 15 meter by second. Okay, now we will see the part B of the question. Both balls have the same mass, but the volume of the plastic ball is much greater than the rubber ball. Okay, this is very important point here. The volume of the plastic ball is much greater. Explain in terms of the forces acting on each ball why the plastic ball reaches the terminal velocity but the rubber ball does not. Okay, so here this is the concept of the terminal velocity, what we should recollect. So whenever the object is falling freely under the gravity, we know that in the downward direction, basically the gravitational force or the weight of the object is acting, and in the upward direction we get the air resistance in the upward direction. Okay, so this we can say it is nothing but the gravitational force, or that is nothing but, in the simple word we can say it is nothing but the weight of the object. And in the upward direction we have the air resistance. Okay, this is nothing but the air resistance. So these two forces are acting in the opposite direction, and when these two forces become equal, then the constant velocity, that is nothing but called as the terminal velocity, is achieved. But this weight of the object, this solely depends on the mass of the object. Okay, if the mass is more, then weight will be more. But in our question, you can see the mass of both the object is same, so weight will be the same. But the air resistance, this depends on the volume or the area of the object. Okay, the surface area of the object. If the volume is more, so here you can see the plastic ball is having more volume. So more volume, that means it will be having the bigger surface area, and for the bigger surface area, the air resistance will be bigger, and that's why the air resistance acting on the plastic ball will be more than the this rubber ball, and that's why the plastic ball will achieve the terminal velocity, because soon the air resistance will be having the equal value with the gravity or the weight, and the two forces will be equal and opposite at that time, and the plastic ball may achieve the constant velocity or the terminal velocity. So you can write down over here the air resistance on the plastic ball is larger due to its larger volume or area. If the volume is more, you can see the area will also be more. So for the large volume or the surface area, the air resistance for the plastic ball will be more. but for the rubber ball it will be smaller, and because of the smaller air resistance it is not enough to balance the weight. But for the plastic ball, that air resistance will be enough to balance the weight. And when it is equal and opposite to the weight, then only we can get the terminal velocity. So we can write down for the rubber ball, the air resistance is not enough to balance weight. Okay, it is not enough to balance the weight, but for plastic ball you can write air resistance is enough to balance the weight. Okay, so weight of the both the object is same, but due to the higher air resistance of the plastic ball, this air resistance is enough to balance the weight, and only when the air resistance and the weight are balanced, the object will achieve the terminal velocity. So this answer you can write down. Then the C part of the question, the rubber ball has a mass of 50 gram. Calculate the gravitational force acting on the rubber ball. So the gravitational force is what? It is nothing but the mass into the acceleration. So you can write down here the weight or gravitational force. Gravitational force, that is nothing but the weight. You can write down either. Writing down both is not necessary. That is nothing but mass into acceleration due to gravity, that is given by the letter G here. So we have to convert, first of all, this is given in terms of the gram. So we have to convert that gram into the kilogram. So 50 gram is how much? 50 gram is nothing but 0.050 kilogram. You have to multiply that with 10 raised to minus 3. So 50 into 10 raised to minus 3 will become 0.050. And the value of the gravity is nothing but 10 meter by second square. So it is actually 9.8 meter by second square, but for simplification you can simply write down it is nothing but 10 meter by second square. So 0.050 into 10, the value is nothing but 0.5. 0.50 value you can write down. The answer is given in terms of the Newton, because so here weight or gravitational force is given in terms of the Newton. So final answer you can write down 0.50 Newton. Now the question number 2. Figure 1.1 shows speed time graph for a car traveling along the straight road. The graph shows how the speed of the car changes as the car passes through the small town. So here you can see it is nothing but the speed time graph given over here. On the y-axis speed and x-axis is nothing but time. So at point A, journey started. The speed is, you can see the speed is decreasing, and at this point B it enters the town, and from point B to C the speed is nothing but constant, and from point C it leaves the town, and again you can see the speed is increasing till point D. So this is the graph. So the part A of the question, describe what happens to the speed of the car. What happens to the speed of the car? So here you can see this itself is a speed time graph only, and the graph itself is directly showing you the speed is decreasing from A to B, and from B to C it is constant, and from C to B it is nothing but increasing. Or you can also interpret it nothing but in terms of the acceleration. So here you can say the slope of the speed time graph is nothing but acceleration. If the speed increases, we can say for the straight line it is a constant acceleration. We can say from C to D, here you can see the speed is decreasing. So this is nothing but negative slope rate. It is called as negative acceleration, or we can say it is nothing but the